Hello, Utala. Now only we can see only 9 students. Kakia. Tarahana dan kabugi or heal. But anyway, that is the challenge we should give to you. Huh? That's a challenge you should take. So try to do something. So this is the assignment on innovation. Assignment on innovation. Probably you can note down this. Put up, the slide there.
Yes, sir, we can see.
So you can write down this and work on this later. පස්සේ කියලා දෙන්න කොහොමද innovations වල how to get ready for the innovations. Later I will share with you. But now you can proceed by yourself. So later when we meet physically in the classrooms face to face, we will discuss more on innovations. Right? But this is the assignment for you to get a new title. Okay? New title. So currently, if no one has patents or some creative contributions, you have to carry that. Okay? So now back to the lessons. Back to the lessons. Can you see the back to the lessons slide? Back to the
Yes,
lessons.
yes.
Good. So when you learn the lessons, you have to bear in mind that first thing, you have to believe the lesson first. You have to trust the lesson, not to say believe. You have to trust the lessons first and try to understand it. Okay, that is very important. You have to trust it and try to understand. The trusting in the sense, you trust that this helps you. Okay, this helps you. Also, you trust that this is a new knowledge, even though it may be the same thing you already heard. But when you listen again, you can believe that you will be understanding it in a more better ways and more productive and useful ways to contribute. That's why. So first you have to trust, you have to understand that, and at the same time you have to be mindful that how to make use of that knowledge. That is very important. How to make use of that knowledge. So this one is not after learning, while you are learning. This inquisitive nature, this question should be lying underneath of your learning exercise. What I can do with this? What's the use of this? Of course, positively. How should I make this lesson real to myself and the others? So you have to have this mindset when you are learning. That is very, very important. That is something like you are learning with an objective. You are not just learning to memorize and pass the exams. Not that. Yeah, that is the current tradition we are having. But you should go get rid of that tradition. No matter your lecture is lecturing whatever, but your side you have to have this. Why I am learning this? First, trust the lesson. Right? Then understand the lesson. Underneath, always look for some purpose to make the lesson real for you. That is very important. Sometimes technological, sometimes philosophical, sometimes tangible, sometimes intangible, but all would be useful. That's why. So in that way, you should learn, and even I'm encouraging. When you learn thermodynamics, especially thermodynamics like subject, technical subjects, so you have to Be this in mind. Of course, you have the practicals and all, you have the design sessions maybe, but out of those, yeah, even though those are there, but upfront, uh, be more forward looking with the knowledge. Yeah, that is very important. So here, this slide, this one I got from your notes really. That's why I'm teaching the notes. Microscopic forms of energy. Okay. So then this microscopic means how do we feel this? Means this is something like related to the molecular levels. Okay. Molecular levels. So you cannot see this through naked eye. So only the microscopes can microscope. Huh? Yeah. So that's why this is called the tiny level, the molecular level structures. So there you can see, even though the matter consists of lot of molecules. Huh? So each and every molecules, they have some activities, the movements. Especially here we consider because of the temperature. Huh? Not to say temperature, because of the kinetic energy of the molecules, because of the movements of the molecules and the molecular clusters, or maybe some crystalline forms or whatever. These molecular movements, molecular motions, that is a kinetic energy of the molecules, and that is reflected from the temperature. So that kind of microscopic forms of energy. Okay, so these are related to the molecular activities. Yeah. So molecular activities, and yeah, and they are independent of outside reference frames. You no need to worry about this statement. Later we can understand this when we meet face to face. So the microscopic forms of energy are those related to the molecular structure of a system and the degree of molecular activity. Molecular activity, in the sense here, it is the molecular vibration, okay, and the molecular motions, yeah, together, okay. There may be linear motions, there may be rotational motions, there should be vibratory motions as well, means moving back and forth, okay. So collectively, so this energy, because of the molecular motions, that reflects the temperature as well, and that is we call the internal energy. Because the sum of all the microscopic forms of energy is called the internal energy of a system. Okay, and is denoted by U. Let me explain this further in a better way. Afterward, of course, today I will explain this. Today I will explain this further. So this one, don't try to memorize, but imagine. Imagine. You have to have some little imaginations. Whatever the objects you see physically as big consists of a lot of molecules, and those molecules are really in motion. So that's why those have its own temperature levels and the internal energy levels because of this molecular motions. Now, linear means moving in one direction. Sometimes the rotational, it's turning at the same time. And while turning, this can even be vibratory or moving back and forth. Collectively, that energy due to molecular activity or molecular motion that reflects one way the temperature, the other way. That microscopic, the sum of all, we call it internal energy. So try to understand what this internal energy means. And you have to put a little effort on this because this is a term we are using, but in most cases we are using the increasing or the decrease or the change of internal energy rather than looking into absolute values of internal energy. There are no absolute values, but we are going into the differences, the increase, the change of the internal energy levels. Okay. So if you refer to your, anyway, let me proceed this. So later I will visit your notes as well. So this one again from your notes. So two forms of energy interactions associated with the closed system are heat transfer and work. Can you remember last week I showed you some slides? There you see the system boundary and the surrounding. And the closed system means no mass transfers through the surrounding, through the system boundary. And then only the work and heat, the only two forms, heat transfer and the work. So an energy interaction is heat transfer if its driving force is a temperature difference. Yeah, which means the energy interactions with the surrounding and the system due to the same temperature difference, that is what we call heat transfer. If not heat transfer, the other energy interaction is work. Otherwise, it is work. So let me share with you one more slide here. Work means, you know, the work done is force times displacement. Or force times distance. You have learned this in your A levels, O levels, in your diplomas, but still we have to feel it better. We have to feel it better. Actually, further learning means understanding more, nothing much. Eh? Further learning is something like understanding more and naturalizing the knowledge. If you can naturalize the knowledge or internalize the knowledge, that is what we call the further learning and understanding. So work transfer or work done is the force times displacement, means force acting through a displacement. So the work done, when you quantify the work done, is by two terms, force times the displacement or the distance. So energy transfer associated with the force acting through a distance, we call it work done. Okay, the rising piston in our piston cylinder engines, we know almost all the strokes. Yeah, there are work done, work interactions are there. A rotating shaft, of course, there is a force, but it's turning. Even the electric wire crossing the system boundaries are also associated with work interactions. Means a power supply. The power supply to the heater also associated with work. That one let me explain after this session. So, how the electrical input becomes a work done. Very interesting. Yeah. That is not heat, but it's a work done, but later it changed to heat. Maybe that is it's a different. Right? And this first law of thermodynamics means this is based on experimental observations. Yeah, experimental based laws, the first laws and the second laws of experience or the experimental based, states that energy can be neither created nor destroyed. Means the energy you cannot create, you cannot destroy, energy remains the same level. But it can only change the form, that's all. Either kinetic energy change to potential energy, or heat energy change to work, or work transfer change to heat transfer, and then after that maybe change the internal energy levels. That is what we call the kinetic energy levels. Actually, what I'm telling you are simply some sets of words. But to understand the words, you listening to it and you imagine and based on your knowledge, to convert the words I'm telling into knowledge is something quite challenging in this kind of Zoom sessions, because we don't have the brainstorming. We have no dialogues. So only I am talking like a preacher. So you are listening it. So turning these words into a knowledge is something quite challenging. So we know that. That's why we need both the face-to-face and the this kind of distance learning, the Zoom sessions. We need both. We need both. Otherwise, it's a challenge for the lecturer and also it's a challenge for the student. Of course, if we are smart enough, we can minimize this teaching and learning gap somehow by means of maybe using better videos and explanations or presentations. So we will try our best how to convert this preaching into knowledge. That is very important. Yeah. So that is very important. So I'm going to stop this slide sharing and I will open the notes. I will open the notes for you and let's see where we can see this. Okay. And we will drill these words for you to uh, make these words into knowledge. So I will try my best to help you right now for this. Can you see this? The first law of thermodynamics. Really?
Yes, sir, yes.
Very good. So actually I got it from here because the notes I have provided to you is a very wonderful one. So when I put it into the slide, it looks attractive, but it's the same. See, this is what I put in the slide. Huh? Yeah. The first law of thermodynamics states that energy can be neither created nor destroyed during a process. Process means thermal processes, Putala. Okay, or thermodynamic processes. Yeah, thermal processes or thermodynamic processes. So the energy is not created, energy neither created nor destroyed. So that is experimentally based. Yeah, even that word is here. See, based on experimental observations. So this is a very complete note I used to share with some other students here. Even in previous I shared this, not only with you, but with other streams and other courses as well. So this is a very wonderful explanation. But to turn this into knowledge is something quite challenging. Don't try to memorize this. The memorizing has no use. When it comes to the internal energy, see, I got it from here. Well, this is well written. Okay, that's why I used it. See, the statement was given in the slide. So I'm very open. That's why I gave you the notes. Microscopic. This one. See, these things. So you have to be very patient. Spend a little time. And you try to understand this and this has some practical sense. That's why. In some system designs, optimizations of thermal systems and processes, because this is observation based means this is practical. Right? This has practical aspect. So the only form, two forms of energy interaction associated with the closed systems are heat and flow. Also in one slide. This also I put in one slide. Also I put this as another slide. So I'm not doing magic. Yeah. I'm not doing magic, but I make it convenient for you to see. So this one also explained. Yeah. So slowly try to understand this. Means, improve your understanding and your imagination. control volume. Okay, even let me control volumes. This one, if I put into a slide, you will see a wonderful, wonderful slide. Be patient, be patient. I'm going to share that. See, another statement. When I put it here, it looks good, but you should learn how to read the text as well, because it's a useful text. So I got this from the text. The control volume can also exchange energy via mass transfer. Means through the system boundary, a mass transfer also possible. Okay. Yeah. So when the mass transfer, the energy content of the mass is also transferred because the energy is contained within mass. If there is no mass or no matter, there is no energy to carry it. Yeah, that's right. So that's it. So let me stop this and I will go to my previous slides. Okay, previous slides. Previous slides. Can you remember the field it slide? So I'm going to that field it slide. Field. As a refreshment. See the boundary here. They are also related to today. Few slides I shared with you earlier. That's with you as well in a text form. Uta, can you see this? Fill it slide. Can you see? Pin on the screen again. Pin on it.
Yes, sir.
Okay, very
Oh,
good.
yes, sir.
Very good.
Yes, sir.
So you can see the system. System means it's a mess. Okay, it's a mess. And of course, system is surrounded by what we call the surrounding, the name itself. And the demarcation of system and the surrounding is the boundary. So depends on our analysis, you can identify what the system means, what the surrounding means, and then you know what the boundary or the interface means. So, yeah. Also, you should know about the spaciousness. So this one go through the system, boundary, and the surrounding. Okay. You can see the boundary and the surrounding, and there should be some communications between between the system and the surrounding through the boundary. This communication in terms of transferring, the key word here, transfer. Okay, transfer energy and work and mass through the boundary. So this is a very good sense for this word. So when it comes here, transfer, notice the word transfer, notice the word energy, work, mass, again the substance through the boundaries. Means energy and work and even the mass cross the boundary from the surrounding to the system or from the system to the surrounding. Okay. So when there is no mass transfer, yeah, this slide is very important. Eh? So always keep in mind that you are learning for those who didn't learn. That's why so you have to be very serious. Very serious in learning. You have to be very serious. If you earn something, right, if you're going to have a wealth for you and those who are needy, that is very important. So you have to have this. Yeah. And also you have to be strong. Yeah, you have to be strong. And you should be very generous. Right? So when you learn, for those who didn't learn, and also for you, you are very generous. And that's what we call generosity. Generous doesn't mean you are giving money to all, no such thing. Generosity means a quality that we should carry all the while. Generosity. So even I gave you the challenge because of the generosity. So I it is not necessary more for me to ask you to be innovators. But true, I can share the text. That's enough. But since I'm generous and I want you to be someone, somebody for you and for the society. So why not I give you a wake up call. Yeah, that's the generosity I'm showing you. So when you are learning, you should have that generous quality as well. Yeah, that's why the generosity is finally that is the thing govern the world. So you have to be strong. You have to get the wealth. You have to get rich. That's not right. Yeah, you have to. Yeah. There are purposes, and many more. So this is a very wonderful slide. So when this is real, this is real. This is real. So when you have this mindset, there is an advantage. You have the blessings from the universe, and you will be on right track because you are on a mission with a vision. Okay, with a very great vision. That's why. So you have to be strong. That's why you have to do the innovations. You have to have the innovative skills. You have to have that mindset. Whatever you are learning, you have to make it real. Yeah, very good. So this is master slide. Later I can share with you these slides. Don't worry. Yeah. So even we all are like this, They may be looking for some materialistic thing, but we all are like this somehow or other for different purposes. Maybe you are yearning for the knowledge to receive for you. But see this hand. Can you see this hand? Tapeno. මොනවද දින අත පේනවනේ. පේනවනේ. See the generous hand. Delivering to all. පුතා ඇහෙනවද කියන එක? Can you see the slide?
Yes, sir.
Yeah. So where you have to be. Now you are here, but later you should be here. Okay. The hand of this generosity. So this is a wonderful slide. Yeah. That's why when we learn thermodynamics, it is not only thermodynamics. So when you have this kind of very good attitudes, your learning will be very strong and you will be gifted afterwards. That's why. So you have the purpose. You have the purpose. Even the teaching for you, we have a purpose that is more than giving a knowledge. Yeah. Let me skip this. Back to the slides. Yeah, actually that one also because you are you and the surrounding. Yeah, you and the surrounding, the connection. Finally, all are together. That's why. So here, the matter and the surrounding, the systems and the surroundings, the connection, giving and take, the same. So you can see surrounding is great somehow. Yeah, but the system is important. System is important, but the surrounding is what is great. Maybe. Yeah. So again, transferring. Yeah, same slide, but very interesting. energy and work and mass through the boundaries. Right? Through the boundaries, from surrounding to the system and from system to the surrounding. Interesting. So here you see the system boundary again. So heat from and to the surrounding, work from and to the surrounding, so energy in this way, and the mass from to the system and also from system to the surrounding and to the boundary. No matter this is a piston cylinder or no matter it's a turbine or no matter this is a incinerator or no matter this is a boiler or no matter this is a power plant. Okay, whatever. When you identify the system, it is something like this. Okay, it is something like this. Of course, when you look into further details, again it is something like this. Yeah, that's the simplicity of understanding. Finally, this is itself. Yeah. If you know this, if you feel this very well, you are done. Okay, so matter and the surrounding, the state of equilibrium means nothing interacting. It doesn't mean this is isolated. This is together with the surrounding, but no heat and work transfers, no mass transfers. System remains, the surrounding also remains. This is something like what we call equilibrium, the state of equilibrium, and this is the definition. That's why. So when you see this, and if you have some photographic memories on this, and now you can imagine the system, you know the boundary, you know the surrounding, you know the interaction, the Ganudenu, giving and take between system and surrounding, energy and work, and in terms of mass. Yeah, quite nicely you can get this into your fingertips. Yeah, that is very important. And after that, we are going for specific. No energy interactions, no matter interactions, but system together with the surrounding. Yeah, this is so-called equilibrium. So-called equilibrium. No transactions with the surrounding, remains as it is. This is naturally we call it's a natural state. The possibility maybe it depends, but this is what we call the equilibrium state. So in equilibrium state, there is no change of the properties here in the system with time, no change. Okay, means the system remains the same property, same pressure, same temperature, same mass, same energy levels, same volumes, whatever. All the physical properties belongs to the system remains as it is, irrespective of time change. Okay. That is interesting. So it's the same here. Okay. It's the same here. Right? Yeah, it's the same here. So see, no means nothing. See, absence of the arrows. System is system, surrounding is surrounding. So that is what it says. Absence of arrows, red arrows. Yeah. So I hope you can imagine it better now. But once, of course, start from equilibrium. When there are energy and mass, energy, work, and mass interactions, no more it's in equilibrium. The states are changing, and finally, at the absence of this, again, this will come to the equilibrium state again. So initial to final. Okay. Yeah, here we have only few minutes in this, and this will restart. So we have to be patient afterwards. Once this is cut off, I have to come back again because uh, we have to talk about this energies, internal energies. Yeah, that's all. So this one we have discussed last week also, but here again we happen to discuss this. Now you see in the middle figure here. So course, when you have this heat interaction, what change inside heat and work interactions? What change inside is the energy level. That changing energy level, the type of energy we call internal energy. So when heat interacts, when work interacts, molecular motions change, movements of molecules change. Thereby, the internal energy levels change. Okay. When the mass comes or mass leaves, what happens is together with mass, the internal energy itself of the mass also will come or will go. Then the system internal energy level will change. Okay. System internal energy level will change. So I will cyclicity later we will discuss. So if we come to this, okay, in this process, now here no mass transfer. Then we call this closed system, the non-flow process. Closed system or non-flow system, non-flow of matter during the process. Okay, so this all the keywords are there. Okay, so when there is no mass flow, and only because the matter flows, but energy and heat transfers to the system, what happens is because of this energy transfers, the energy level of the system change. The changing type of energy, we call it internal energy. So that is related to the energy change because of the heat and work transfers. So heat and work transfers change the molecular level motions. Microscopic energy level will change. So that change we call delta U in the third picture. I'm circling here with the mouse. Can you see? So that's why. So we have net energy in is same as the internal energy change finally. So you have initial, you have final state. So the change of the energy levels is this, and there will be a change of the processes. So we have 1 minute left for this session, and this will restart again. So you have to wait for another session. So I believe you can have some little, how to say, photographic memory of this. So energy levels, energy means heat and work. Right? Heat and work. Energy transfers from O2. So whatever the change transfer is the same as whatever change here